Hi, this is the Unit 3 carboxylic acid first lecture. It's an introductory lecture. So in Unit 2 so far, we looked at carbonyls in aldehydes and ketones. And notice the oxidation level of aldehydes and ketone was 2. And the reason why these two functional groups were grouped together in one chapter is that they did a very similar type of chemistry. And now in Unit 3, we're about to embark on another set of functional groups in which the carbonyl, we're continuing with the carbonyl. So the C-vinyl is still present. But what is different from aldehyde and ketone in Unit 2 is what I've used Z as. In other words, instead of a hydrogen in aldehyde or a carbon, which causes it to be oxidation level 3, now I have an electron withdrawing group represented by Z, bonded to the same exact carbonyl. All right, what that does is that it causes this carbon of the carbonyl to have oxidation level of 3 rather than 2. So one level higher than aldehydes and ketones. And all these functional groups that you see on the right are grouped into this same chapter, Chapter 21, because 1, they're in the same oxidation level. 2, much of the chemistry is very similar. So once you understand the mechanism of how these functional groups behave, then you pretty much can predict what the products are going to be regardless of what Z is. All right, so that's why they're lumped up together. So well, at this point, what I'd like you to be able to do is substitute the Z. So in other words, if Z was OH, that functional group is called carboxylic acid. Instead of an OH, if Z is an OR, so the R group could be anything, then that functional group is ester. If Z was Cl or chlorine, then that functional group is called acid chloride. If Z is oxygen followed by another carbonyl with an R group, that functional group is called anhydride. Just for you to be able to visualize this, so you have a C-O and an oxygen and another C-O. That's an anhydride. So you could have different R groups on it, but the oxygen with 2 carbonyl flanking it is an anhydride. And then if Z was C-O and then nitrogen, some sort of nitrogen, it could be 2 R groups, 1 R group, no R groups at all, it could be just NH2. Those are classified as amide. All right, so what I'd like you to be able to do at this point is see this very complicated structure. I want you to be able to look at that complicated structure and be able to circle, recognize and circle the different functional groups that you just learned. All right, so for example, the C-Cl is an acid chloride. Notice this is a anhydride. This is carboxylic acid. And notice this has a C-O with an R group with an oxygen and in a cyclic pattern, but this is still an ester. And then here you have a C-O with a nitrogen, and that is an amide. So that's what I expect you to be able to do before you come to the lecture, so that you could instantly recognize the different functional groups and what family they belong to. All right. So we're going to start our discussion with carboxylic acid, and we're going to proceed to the all the other 4 functional groups after we finish with the carboxylic acid. All right. So carboxylic acids are abbreviated So the functional group looks like this, C double N O OH, but a lot of times it's not written out, but it's abbreviated as a COOH or RCO2H most often. So those are the abbreviations that you'll see for carboxylic acid. All right, and what I've drawn briefly are the some of the most common carboxylic acids that you may run into. So for example, probably one of the biggest reason to understand carboxylic acid is the fact that it's part of one of the functional groups of amino acids. So in Unit 2, we're going to be looking at amino acids and proteins, and obviously you need to understand the chemistry of a carboxylic acid, and then this unit we're also going to look at amines as well, so that by the time that you get to Unit 4, you understand both functional groups in amino acids. The next structure that you have there next to amino acid is the structure of aspirin. And you should take a look at the in your book, page 999, because it goes over how aspirin works in your body when you take it to get rid of pain. We will not go over that yet, but later on, after we learn the chemistry, it will make a lot of sense to you. So after we go over the chemistry of esters and etc., you should go back and look at this page 999, read it, because then you'll understand how aspirin works. Next to that is an Advil. So these are a lot of pain relieving medications. And then probably the most simplest acid that you know is vinegar, shown there by acetic acid. So its IUPAC name is ethanoic acid, but most of the time is referred to as acetic acid. The one below that is butyric acid, because it's got 4 carbons, and that is what's responsible for sour smell when you when butter spoils. And these, I mean, vinegar, as you know, has a pretty potent smell. So that smell kind of is continued in liquids. So, for example, the hexanoic acid, which is this last one right here with 6 carbon, is what is responsible for body odor or dirty socks that you smell. So these liquid carboxylic acids often have very a potent vinegary type of smell to them. All right. So nomenclature-wise, it follows the rules that you've seen before when you named other functional groups. So basic rule is that you drop the E from your parent and add oic acid. All right. Now, in terms of ranking for numbering or ranking in terms of which functional group gets the highest priority, therefore is named as a parent, the acids have a pretty high, it's the highest ranking. So it will always get number 1 in numbering. And you will number from there to the other carbons, and all the other functional groups will be named as substituents, all right, because they have the lower ranking. All right, so because you always give carboxylic acid as a number 1 in numbering, it's understood. So you don't usually see 1 in front of the carboxylic acid name, because it's understood to be number 1. All right. If you have carboxylic acid outside of a ring, then you name this first, which is cyclohexane. Sorry. And then you name this as a carboxylic acid. So this name will be cyclohexane carboxylic acid. If you have more than one acid, like 2 acids and 3 acids, then you just go by the di in front of the oic acid, so dipentanoic acid. So you would have a di and then parent and then oic acid. Actually, no, sorry about that. It's dioic acid. Something's pentane dioic acid would refer to total of 5 carbons, and then you have 2 carboxylic acids at the end. Okay, and then your book has a lot of common names that they want you to memorize. I don't want you to worry about that. All right. So just to do an example, so here's a carboxylic acid, and when you count up the numbers, make sure that carbon of the carboxylic acid is part of the number of carbons that you count. Okay, so the phenyl group is going to be substituent. So the longest carbon is 1, 2, 3, 4. So you always include the carboxylic acid carbon. So is it would have been butane, but then there's a double bond here, so it's butene, and then you drop the E and then put oic acid, so it's butenoic acid, and you number from here 1, 2, 3, 4. So once again, you don't have to say where the oic acid is. It's understood to be 1, but you do have to say where the double bond is. So it will be 2-butenoic acid. And if you want to be really detailed, you could even put the E to refer to the trans of the double bond. And then on the 4th carbon, you have a substituent phenyl. So the complete name for this compound is 4-phenyl-2-E butenoic acid. All right. Secondly, if you have a name and you need to draw it, the best practice for this type of question is you go to the end and draw that first. Hexane is 6 carbon. So I've drawn the 6. Hexanoic acid, it doesn't matter which end you choose to be the acid. Either this one or this one is fine. But since I drew it on the right, this is going to be my carbon 1. And notice on the carbon 3, I have a methyl group. Carbon 5, I have a methyl group for the 3,5-dimethyl. And then on the carbon 4, I have ethyl group. All right, that's the carbon skeleton. You go back, put in the right number of the hydrogens, and then you're all set with drawing given a name. All right, so that concludes this introduction, and I'll continue with properties of carboxylic acid in the next lecture.